Alright, welcome. Today is March 18th, Wednesday. It's supposed to be a short day today. I'll try my best. I keep trying to cut down on the time and it keeps on running for like an hour. I don't want to do an hour lecture. It's kind of too much. But today I hope that it'll be shorter and it's going to be more on you, so more things to do for your on your end and less of me just talking and rambling. So welcome. Thank you for tuning in. If you're here, please go to ClassFlow and answer the two questions that we have. We have a few people, actually just a few people who have signed on. Only two have answered. Shiraz and Adam, very good. Chat, are you up there? Oops. Here we go. Today we're going to talk about series and parallel, but more through discovery rather than just me telling you what it is. So you're going to figure out what these two words really mean when it comes to circuits. What is the ClassFlow link? It is QGX7X. QGX7X. Whoa, there's a squid thing. How do you do that, man? Alright. Anyway, ClassFlow it up, go and answer. The question is, you're using two AA batteries in your remote control. How many volts does it need? And the other follow-up is that the stylus that you use for your HP laptops uses a quadruple A battery. How many volts is that? So, two easy questions. If you look at the side of your battery, you can see the voltage on it. It'll tell you. And what's interesting is what I want you to notice. Remember, we don't just answer questions for the sake of answering questions, right? What do you notice? What pattern? What can you say based on the two questions that I asked? Fast butter. Hello, fast butter. All right. Anyone notice anything? Well, let's see. Let's see our answer, shall we? We have a few. Whoa, we have several answers. But people are still waking up. I don't think there's a conference call today for what is it? Calculus BC. Dalsas. Make sure you thank Mr. Dalsas because he's decided to hold his conferences at a later time in the afternoon so that it doesn't coincide with AP Physics 1 and C. So make sure you thank Mr. Dalsas for doing that so that we can keep our stream times the same. Yeah, but there's always ROTC. When is ROTC? Isn't it in like the morning or something? Don't you guys have to wake up at like 4 a.m. and do your ROTC stuff? Isn't that how it works? Go running or something. Alright, anyway, I'm going to close it since 10:23. Oh gosh, he actually does it by periods. That is unfortunate. Well, you can always catch the VOD on our YouTube page. Speaking of which, make sure you subscribe to our YouTube. We need more subscriptions. We're getting closer to our 100 goal. As soon as we get that 100, we get our custom URL. Alright, let's see some answers. 3 volts, stylus 1.5. Ooh, most of you got it, very good. Just one, unfortunate. So yeah, a AA is 3. Well, one AA is 1.5, but if you use 2 and they're connected end to end, then you get the whole 3 volts. The voltage basically comes from the chemistry of the battery, the type of material that you're using, alkaline and all that stuff. I'm sure you can learn more about it. If you want to learn more about it, consider taking AP chemistry. And I'm sure Mr. Lin or Saka will teach you more about batteries. And I think they make a battery or something like that. But in any case, whether it's a AA or AA, AAA, quadruple A, It's all 1.5 volts. Oh, that's not a quadruple. There we go. 1.5. Ooh, that's not a 1.5. I am not ready to stream today. 1.5 volts. There's also like D cells and C cells. What are the difference? They're all sizes. They have different capacities. Okay, of course, a D cell are those big giant flashlight batteries that you use. They're still 1.5 volts each. It's just they run for a very long time. So whenever, in an emergency, you always want to make sure your flashlights are ready to go and don't have to look for some AA battery. So you put in some D cells so they last for a very long time. And the flashlight light itself, the light bulb, doesn't use that much power in the first place. And it does depend. Technically, you can get super bright flashlights that can basically make the night turn into day. Alright. So that was that. Good job for what is that? 7 out of 9? No, 8 out of 9. Alright. Our pass rate is pretty high. Very good. I'll accept that. Today, let's go to our website and then download the Circuits 101 lab. This is to get us started. So ideally we would do this on an actual circuit board, but we're going to use the FET simulation kit to do this. Okay, so go ahead and download this. It should look something like this. It's 2 pages, and the goal is to answer all of this. This is something that would go in your 3-ring binder, assuming we still have a Q4 binder. So put this in your activity section. There's no more labs in Unit 8. All of this stuff just goes into your activity section. So there's 2 circuits that we're going to investigate, and then we'll try to look for patterns purely based on our own observations and our own measurements. Okay, so we're going to do this using the circuit kit that we used yesterday. So you want to go to FET simulations under physics, circuits, or just Google circuit construction kit DC virtual lab, and it will come up. All right. Very good. We're getting more viewers. That's good. If you want to chat, make sure you hit the follow button, and that should allow you to chat. If you just want to lurk, that's also okay. We accept lurkers. All right. So open up your DC circuit kit. So wham, hit play. And it should look like this. Okay. There it is. Charmelon. No, Melion. Okay. Oh, I get it. Charmeleon. Like Charmeleon. Wireless high five to Charlene there. I'm sure that's Charlene. Alright, so this is what it should look like. Now, we want to talk about how to actually make measurements, right? So we use a voltmeter, or technically a multimeter. Multimeters measure multiple things based on what setting you set it at. Multimeter. And we have a multimeter that looks very similar to the virtual one. It's actually orange, so let me use orange. So it looks something like this. Okay. There's a screen on it that gives you the values, of course. There are 3 ports or connector pins, but you only have 2 probes to connect them. Okay. The middle one is called COM, or common, and that's the black probe. So the probe is a connector. It connects into that port, and it basically looks like a pencil, or a really cool pencil. Okay, it's a very pointy metal pin at the end there. Okay, basically you use this pointy thing to touch or make contact in your circuit. Okay, and finally, there's also another probe, the red probe, and that can kind of connect to either ends based on what you want to measure. In our multimeter, we have to actually swap probes from one connector to the other if we're measuring high currents. So the left one is used for very high currents up to 10 amps. Typically, we just leave the red connector on the right side, which measures everything else. So it measures voltage, V, measures ohms, omega, measures temperature. So this is what I used for our temperature probe when we did our PVC pipe resonance lab. And so we connect the red probe like so to the right side and just leave it there. The right side is also able to measure small amounts of current up to, I believe, 300 milliamps. Can't remember the exact number. So if you're measuring 300 milliamps, then you can just leave it. If you know that you're going to go higher than 300, then you have to swap your red probe from the right side to the left side. The common stays where it's at. It stays in the middle. You don't actually swap the probe, the black probe. You just leave it where it is. What does that stand for? Common or ground or 0 volts. It's your yeah. All right. So the red probe connects to either the right side or the left side based on what you want to measure, voltage, amps, temperature, and it can also do up to 300 milliamps of current, so small amounts of current. Okay. Now, based on the type of multimeter you buy, it could be like this or it could be different. Just make sure you look at what it's measuring. And finally, in the center, there's a dial, and the dial is what you turn or change the setting of your multimeter. Typically, the resistance values are somewhere around here. So there's different resistance values that you can measure. There are voltage values that you can measure over here. There's even some other fancy stuff that we're not going to talk about, like temperature and continuity tests and some other stuff. And of course, there's some current somewhere around here. There's also V with a squiggly. The squiggly is basically AC, alternating current. So when you have alternating current, you also get alternating voltage. But V with a bar means DC. So V with a bar is from DC voltage, which just means that it is a constant value. Okay. Whereas V with a squiggly is from AC, which is alternating. And just like the symbol, it's sinusoidal, so it's moving back and forth, changes between positive and negative. Like a sine graph. Okay. Now, typically, the multimeter won't be able to measure that. What it does is, measure some sort of root mean square value or something like that. But again, depending on your voltmeter, you can also use Logger Pro with a differential voltage probe, which can measure voltage as a function of time, and that will actually give you the cool sine graph. If we ever go back to classes, then we can actually show you all that. All right. So based on your setting, we're going to make measurements of different things. If you want to measure voltage, so here's some rules of using a multimeter. Rules. Okay. So let's start with resistance. So measuring resistance. I should write making measurements. Rules for making measurements. Okay, number 1, resistance. Okay. Now with the virtual lab, you're not going to actually measure the resistance. We're just going to have to manually set the resistance of a resistor, and that'll be it. But in reality, if we were ever doing our lab practical exam, this is what you would do. So for resistance, disconnect resistor from the battery. Okay, meaning don't attach anything to the resistor. It can be in the confirmation of your circuit diagram, just as long as it's not a closed circuit, so that the current can flow. You just need to make sure that the current is off, or the current is not flowing in your system by having a break in the system. That way, nothing is going through the resistor. What the multimeter does is actually sends its own current through the resistor, and then uses Ohm's law, V equals IR, to figure out what the resistance is. Whatever voltage it's trying to send through, and the current it's reading, so V divided by I, it'll pop out a value which tells you what your resistance is. So first thing you do is disconnect the resistor from the battery, and then make contact with the top and bottom parts of the resistor. Now typically resistors have a little metal connection port or metal part on its sides. You want to make sure you make contact metal to metal. If you actually touch the body of the resistor, then it doesn't actually do anything. So make sure you make contact with the metal parts. Not the body. Okay, and that's it. So resistance is very easy. You just make sure the current is off, and all you're doing is touching the resistor. So in a diagram, it would be, remember it's a squiggly. So basically, we would use our probes to touch the metal part here and the metal part here. It doesn't matter which side you put the red probe or the black probe. You can touch either, and it's okay when you're measuring resistance. Okay, so for resistors, it doesn't matter which way you send the current. The resistor works the same way, whether you're driving forward or driving in reverse, doesn't matter. Okay, it's still going to slow down the current by the same amount. And when you have AC current, what you're doing is actually sending the current forwards and backwards over and over again. So if you have a heater, an electric heater, that is sending AC current into it, it'll just go back and forth, which essentially heats up the resistor, giving you the heat in the first place. All right, and if you use your virtual kit, so in the real life model, so this is what a typical resistor may look like. Of course, you can have smaller sizes, bigger sizes. They have little stripes and bands, color code, and using those color codes, it is possible to actually know what the value of the resistance is. But in AP Physics 1, we don't have to know what these stripes are, nor do you need to know it in AP Physics C. But if you want to become an electrical engineer, consider learning the code, the color code for resistors. Well, we need to learn the color codes. Chat, do we need to learn the color codes? The answer is no. Not for AP1 nor for APC, but you do need to know if you want to become an electrical engineer. All right. How's the delay today? Is it longer than usual? I feel like the delay is longer. And I still haven't figured out how to decrease the delay in Streamlabs OBS. If anyone knows how to decrease the stream delay on Streamlabs OBS, type in chat. We're losing our viewers. Oh man, people are getting bored, I guess. All right, we'll move it on. The other two is the two that you need. Slightly longer? Yeah, I think so. I think it's like 3 seconds now instead of 1 second. Resistance, so that's over with. With current, okay, you would have to have the current, have the battery connected. Battery is connected. You have to make a break in the circuit. So make a break, meaning a hole, or just cut the wire. Break in the circuit. Oh, this is terrible. Break in the circuit, and then touch or make contact with your probes at the break. It doesn't matter whether the break is in front or behind the resistor. In front or in the or behind the resistor. Okay, and then make contact at the break. And I'll show you what I mean with the virtual simulator in a second. And finally, the third one, which is the easiest, just as easy, which is to measure voltage. Okay. Entire circuit is connected, so circuit is connected with the battery, of course, your power source. Okay, and no breaks this time, no breaks, but just make contact with the probes across the resistor. Make contact with probes I should say at the front and back of the resistor or other circuit element. Oh, not or, and. Front and back of the resistor. Alright, simple as that. So here are the rules. Resistance, disconnected from the battery first. Make sure no current is flowing, otherwise you're going to damage the multimeter itself. Make contact with the top and bottom part of the resistor, and then that'll give you the resistance. Again, with the virtual lab, there is no ohm meter setting, so we're just going to set the values of our resistor and be done with it. With our current ammeter, so we use an ammeter. So an ammeter, remember, meter is a suffix for making measurements of whatever's in the front. So ammeter measures amps. We're dropping the P because it sounds better. Ohm meter would be what measures your ohms. And of course we have voltmeter. That measures your volts. The symbol, circuit symbol, would be circle with a V. Here we have circle with an A. And finally here we have a circle with an omega. So that's the circuit symbol for each meter itself. So if you're going to put a meter, a measuring device in your circuit, you would use a circle with whatever you're trying to measure. Okay. And we'll talk more about it when we do lecture tomorrow. All right, so your task is to build the circuits and make measurements and then fill out all of that stuff. So here's a resistor, typical resistor. Let's go and create a quick circuit. So I need a battery. Boom. And to use the simulator, you can actually click on your objects and then set the values. So if I click on the battery, I can set the value. I'm going to set it at 3 volts. So make sure you set your battery at 3 volts, because that's basically what we'll get if we were to do it in school with our double D-cell battery pack. Here's one circuit. Now it is possible, resistor. It is possible to connect resistor to resistor, right? And if you want to undo a connection, just click on the connector in the middle, or double click it, boom, and then, or single click, yeah, and then the scissor thing pops up, and then you can cut it. Right. I'd like you to put a wire. Don't actually connect them end to end. So make them slightly more realistic. So put a wire in between, like so. Okay. Of course, you're going to do it with 3. I'm going to do it with 2, so you can't copy my values. And then a wire from the resistor to the battery, a wire from the resistor to the battery on the other end. And now it's on, and you can see the little tiny balls are moving. Those are electrons. Well, we don't want electron flow. We want conventional current flow. So we're coming out of the positive into the negative. If you look at it in diagram view, click on the diagram on the bottom right, and you can see how the current is flowing through our system. It's very slow, etc. All right, now to actually make measurements. Making measurements. All right, so if I want to measure the current, we take the ammeter. Here's our ammeter. Okay, the ammeter doesn't have probes, so we're going to make our own makeshift probes by attaching 2 wires to the ammeter, like so. So we can treat this kind of like a probe. Look, it has probes, and here we are. So let's say I want to measure the current that is going through these resistors. Now you can set the values of the resistors as well. Okay, so for this activity, for activity number 1, use R equal to 5, 10, and 20 ohms. Okay, but you can kind of decide which one is 5, which one is 10, so you don't have to follow me. That's a 10, so let's make this one 5. Okay, and you can see how the color code has changed. And so it tells you the color code for 5 ohms. So this is 5 ohms, this is 10 ohms. I'm going to measure the current for the 5 ohm resistor, the one with the green stripe, this one. Okay. Again, I need to make a break, which means I need to cut the wire, whether it's in the front or behind, doesn't matter. So let's cut this right here. So now it's cut. And we will attach the current, or the ammeter. Where is this activity? Z Physics, Unit 8, activity, or lab number 1. There you go. And it looks like this. Okay, so once I make the cut, I need to attach the ammeter to my circuit. So we'll attach this wire to the resistor. We'll attach this wire to the other part. And now the current, basically, in order to measure the current, we have to send that same current through the ammeter. Now, it is possible that the ammeter drops a little bit of the current, but it also produces some using its own batteries, so that the actual value of the current in the system doesn't change. So that's how it's doing it on the back end. But in other words, you're basically placing the ammeter in the system so the current can run through it. That way it can tell you how many charges you're you're getting per second, and that's what an amp is, how many coulombs per second. Okay, so here we're getting 0.20 amps. Now if I did it in the front, it doesn't matter, it'll give me the same value. So let's go and cut all of this. Let's go and reattach this one to here. So now the cut or the drop is in the front. We'll attach that to that end, and voila. And we're getting 0.2 amps again. Okay, the flow of traffic is the same whether you're in the front or the back. Okay, if you want to measure voltage, right? Remember, for voltage, we need our circuit to be connected. Let me delete the ammeter and all this excess wire. There we go. Okay, so I just need one wire here. Again, that's just because it's more realistic. All right. And the shape doesn't really matter. That's because the wires are ideal wires. They have zero resistance. In the real world, of course, the more wire you use, the more resistance you're going to build up. And but here in the virtual world, it doesn't matter. Okay. So if I want to measure voltage, take the voltmeter. Look, it has probes. Whoa. And what you want to do is touch the top and the bottom portions of your resistor. So if I want to measure the voltage across this 10 ohm resistor, remember this one with the yellow stripe is the one that's 10, the one with green is 5, and you can change it by clicking on it. Touch one end, this metal part, so this gray part is the metal part, or you can touch the actual wire too. Anything in front of the resistor is A-OK. And if you touch another portion, boom, behind, you get your voltage drop. So that means that the voltage drop across this resistor is 2 volts. Now, if you do red to black instead of black to red, or swap your probes, it's going to give you negative values. So if I put the red one here and I put the black one here, it's going to give you negative values. Because the current is now going in reverse direction into the voltmeter. Okay. Left is 10, right is 5. Yeah, that's on my diagram. Now, when you make it, you can make it however you want. Remember, just to use 5, 10, or 20. You're supposed to use 5, 10, and 20, but in any order, in any combination. I'm just doing a 2 resistor circuit. You're going to do a 3. You're going to do a 3. So if you can see this, that's 3 resistors that are all lined up. And again, you can put 5, 10, and 20 anywhere. Just make sure you actually write it down so I know which one is which when you do it. So make sure you, on your diagram, make sure you write down the values. So notice how it says R1, R2, R3. Make sure you label them. So typically the left one is R1, middle one is R2, the right one is R3. Label them, and then you can write down the values. Okay. Right, so the whole point of this activity is actually to get these values by making measurements and not using equations. Now for power, you'll have to use equations, but that's the only one. So if you look at here, we have resistance values. We'll talk about R12, R13, and R123 tomorrow. At least for now, you can do 1, 2, and 3. But you can definitely do all the V's, all the voltages, all the I's, and finally, all the P's, or most of the P's. P meaning power, and remember from yesterday, power is equal to, oh, let's ask chat. Chat, what is power equal to? I think it's a 3-second delay. I gave you 3 equations for power. There are 3 different ways to measure power. IV, yes, it is IV. Totally intended. Well done. Wireless high five. Alright, now, so that was the voltage across the 10 ohm resistor. If I want to do the 5, you put it in front of the 5 and behind the 5. Voila, 1 volt. Okay. Just write your values. When you write V1, V2, write your values as the magnitude. Don't worry about the negative sign. We can always get rid of the negative sign by swapping our probes, right? And when you get to electrical engineering, you actually have to put down the sign, put down the polarity of the resistor on the top side or bottom side. But until then, we're just going to take the magnitudes and keep it simple. It is also I squared R and V squared over R. Ooh. Shiraz with the other two. All right. So that's how you measure volts. And now, if I want to do the battery, so let's get rid of that. Oops, I can't. Why? Go away. Okay. Let's say I want to measure the current straight out of the battery. So we're going to make a break right here, right in front of the battery. Boom. And then we'll attach our ammeter to it. I like using wires because it simulates having probes instead of just connecting the entire piece. So bam. Look for patterns. Don't just do the assignment. Look for patterns. Our goal is to do the assignment, of course, but observe what is going on based on the two types of circuits that we have. In the first circuit, we have all three lined up like so. And this is called a series circuit because they're all in series. And then the second one, you have to make them all in parallel. Okay, so you have to put them in parallel. So anywhere where you see lines, just use wires and connect them. So if you want to make this, let's just refresh, shall we? Okay, so to make parallel, you have to have 3 resistors, 1, 2, 3, and then connect them. I like using extra wires. Again, it is possible to reduce the amount of wires you use. In the real world, it's better to use less wires because less room for error, less loss of energy, etc. But use the wires, it's kind of like Legos. Connect them, and then build the circuit just like you see it. Battery. Pew. Oh, we want to make sure it doesn't touch anything. Yay! Whoa. But turn off electron flow. We want current flow. There we go. Conventional current. All right. So that is all for today. So the rest is on you. You need to finish up this activity. Have your questions ready for tomorrow. If you're having trouble, don't worry. It is due with book binder 4. So, but do it. This will help you learn. But the goal is to not just write down the values, but look for patterns. And I'm sure if you did your summary, you'll know what to expect. Can you go to OneNote for a sec? Yes. Here you go. What did you want to see? Do you want us to print it or just answer the questions? You can just type it up and then print it out for your quarter 4 binder. All right, so that's it for me. Thank you for tuning in. I'll see you next time.